Now I have to, thank the breakfast staff for, commemorating my speak with serving bacon this morning. It was wonderful. I thought, hey, that's perfect. So yes, there's actually kind of a funny story with the name of this. When Raj asked me, wanted to come speak, he said, hey, you want to come speak? What would the name of your talk? And I just threw this out there just because that's kind of, that's something I'd say. But it was funny because later Trent gives me the schedule and he puts my talk up and I'm like, where did you get that topic from? The title of your talk. And I'm like, and he's like, well, you gave it to us. I'm like, I did? I didn't even remember it because it was our first interaction. So I'm like, oh, okay, yeah, it's good. Let's go with it. So first, I'd just like to thank the Grafana Labs for inviting me here and for setting up this conference because I think it's been pretty cool. It's interesting to see where time series and metrics and gathering of metrics has come in the last 4 years. It's really gone a long way. And I'd also like to thank the Kairos community. They've been really great making this open source project a really big success. So I work at Proofpoint, and I need to explain about who is Proofpoint first. They don't do metrics or time series, but it's important because I give some stories about stuff that goes on at Proofpoint. So Proofpoint does advanced threat protection for your email, social media, network. A lot of big names use Proofpoint to protect their data. I would willing to bet that some companies here, or people here may even use Proofpoint. You may even not realize you're using Proofpoint to protect your email. It's just a back-end system that watches email traffic. We check for spam, threats, all kinds of things. And a lot of big companies use our stuff. So we're pretty cool, it's pretty cool in the threat business. So that's who Proofpoint is. So who am I? I'm a staff engineer at Proofpoint. I work on a lot of big data. I work on a large Cassandra cluster, a large Kafka cluster. My Cassandra cluster has over 70 nodes in it right now. And it's not the Cassandra cluster for Kairos. It's for another product that we use internally. We have a 20-node Kafka cluster. We're setting up Storm to process this data. We process. We have an event system that processes a lot of these email messages or information about people's emails, and we check for threats and different types of things. So I deal with big systems, lots of data. I co-created Kairos Db with my coworker, Jeff Sabin. And I'm also a guy who now stares at graphs a lot. And if you have a lot of systems, you start staring at graphs a lot, which has some side effects. For example, just a little side story. So with Proofpoint, we get a lot of, their campaigns will happen. And we'll see campaigns come in, and this is a graph from the Dridex campaigns that were going on earlier this year. There was some pretty big campaigns happening against companies. And every morning it was, the first thing we do is we get up and look and see what campaign happened overnight, and then see how the system handled that campaign as it went on. And it's kind of funny because my wife would say, are you looking at your graphs again? Yeah, I'm looking at my graphs again, because I have my graphs up on my computer every morning. So eventually you start seeing things in the graphs. For example, like this one. Now I am from Utah, so it's Monument Valley. Yeah, I'm like, okay, I'm seeing some similarities here. But then it was funny because then later I saw this one come in, and I'm like, are the actors, the bad actors, trying to tell us something? Maybe, I don't know, whatever. Let's move on. My boss thought it was funny, kind of funny. He's like, I think they're sending us a message. They don't like us. It's okay. All right. So let's talk about Kairos DB. First of all, who has heard of Kairos DB? Who's actually using it? Oh, man. Okay. Well, you will after this because you're saying it's so awesome, right? Okay. So it was created to solve a visibility problem with systems at Proofpoint. At Proofpoint, we've got thousands of systems. The VP at the time, this was about 4 years ago, we're like, we need better visibility into our systems. What's going on? And it was kind of interesting because at the time, there really wasn't anything out there. There was OpenTSDB, which was kind of what we got inspired from, but there just wasn't much going on. I mean, you had Grafana, or not Grafana, Graphite was out there, but it wasn't going to do the scale and the type of things we wanted to go for. So we looked at OpenTSDB. I didn't like HBase. I didn't like some of the things they were doing. I'm a big Cassandra guy. So, hey, I think I can do this better. So it was inspired by the features of OpenTSPDB. And I like what they've done there because I kind of have to pay homage to it because I think he kind of broke some ground with doing the tags and some interesting things with metric or time series data that I think really revolutionized a lot of the thinking about storing data. So I inspired by a lot of those features. We use a Cassandra backend. We needed to consume both system and application metrics. And currently today in Proofpoint, it consumes over 20 billion data points a month into these. We have about 3 clusters that are pulling in data. Lots of data. And the system, Kairos, scales really well. It's on Cassandra. Everything just scales nicely. If you wanted to consume 1 billion data points a second, you could if you had enough hardware. You just scale it out and it'll take it. Kairos is very, the system is stateless as far as ingest goes, and it just pulls data in really, really well. Here's some features about Kairos. There's 20 plus aggregators that aggregate the data as you're querying it out. There's easy to write plugins. You can expand the code. It's written in Java. It's flexible. It's a flexible type storage type, so you can store ints, or they're longs, floats, strings. You can write your own custom type. You can store some crazy, imaginary numbers if you wanted to. You could create a plugin to store whatever data type you wanted to into the database. There's integrations with all kinds of different systems. Primarily, we use at Proofpoint. We use CollectD to gather metrics from. So we have a plugin for CollectD. There's a Solar plugin that you can send the tags off to Solar or Elasticsearch. Or we pull in data from Graphite. There's the Pickle, is that right? Pickle protocol? Yeah. So we can pull in the data from there. Of course, then there's the Grafana plugin. And we love Grafana. Grafana has been great for us. And we use it. We got dashboards all over the place that shows Grafana. Kairos is easy to set up and administer. You can pull down Kairos. Even without a Cassandra cluster, you can just start it up. It has an internal database if you want to just do some testing, lightweight testing with it. So you just pull it down and start it up. It runs. You can play with it. Then you can set it up with a Cassandra cluster in the back end. And it's fast to ingest data. So this is kind of my vision that was my vision of Kairos when I made it. The Devastator just sucking data into it like crazy. And it consumes data fast. Like I say, you can scale it to consume whatever you want, and it'll pull it in really, really fast. I did one test. I cheated a little bit with some of the protocol because at that point the protocol was actually slowing me down, so I kind of cheated the protocol. But on a single laptop, I had a Kairos and Cassandra running on it, and I was putting in 800 data points a second, or 800,000 data points a second. I was trying to get to 1 million, but couldn't quite get there. But it was just like crazy. But this thing scales out, so you just add more, grow your Cassandra cluster, grow your Kairos cluster, and it'll just keep taking in data. So we're kind of getting into saving your bacon. This is a quote from the author of TS Cache. He wrote this to front Kairos. And write once, read never. Kind of an interesting adage, but the point is the data can't help you if you don't have it. And so write lots of metrics. Put this into your system, because it's your kind of like insurance. You're hoping you never have to take it out, but if it's not there, insurance isn't going to pay you. So the only caveat of that, and the previous speaker kind of mentioned to this, is you want to save a lot of metrics. Just be careful how often you save those metrics. Actually, there's an interesting story on this. We collect metrics from CollectD, and the operation said, hey, we use a lot of virtualization. So we have VMs running stuff, and they said, well, hey, let's put CollectD on the host VM and start collecting metrics from it as well. I'm like, okay, sure, that's cool. And the problem there was you put CollectD in it, and if you've collected CPU metrics, there's like 8 or 10 metrics per core, and then you put it on a machine that has 120 cores, and it's collecting all these metrics. It was interesting that actually CollectD started slowing down, and and I don't know the ins and outs of what it takes to collect metrics from your CPU. But it obviously takes time. And what was interesting is that we put that on there, and it was collecting every minute. The metrics coming out of Collect D started to get behind. And they were interesting because they were still reporting, but they were behind. They started, eventually they were 5 minutes behind, and eventually they're 10 minutes behind, but they're still reporting. We found out that it takes longer than a minute to collect the CPU metrics from 120 cores on a machine. And so we had to change the interval down to every 3 minutes just so that it could complete that cycle before it actually reported, so that, because what was happening is Collect D, that one metric was slowing everything else down that Collect D was pulling in. And because it took so long, then it would take so long to report. And so you have to be careful how often you report your metrics, but definitely restore a lot. If you don't have it, it's not going to help you. So now what metrics do you want to store? Now this is kind of funny because metrics are everywhere, and I realized, and who has seen the Matrix? I'm familiar with it. Okay. I realized as I was, as I'm moving along through time series, all those numbers, that's time series data. That's what it is coming in. I was always wondering what that was when you go into the green screen, you see all these numbers flying by. I was like, oh yeah, it's time series data. So it's everywhere. I have a little funny story. So I had a little Neo moment when I was at the grocery store. And I won't say whose name it is because I don't think they would want me to tell what they do. But anyway, I was in the grocery store, this particular grocery store, and I'm sitting there in the checkout, and I had that little Neo moment. I'm like, wow, there's metrics all over here. Look, I could put a metric on the number of items that they purchased, and I could tag it with the aisle and this grocery store, and you could then graph that, and you could get show a graph of when you have high customers coming through your aisles, and then you could adjust how many people you have on staff to open up more aisles, and all this started going through my head as I'm trying to check out through the grocery store. And I just thought it was kind of funny because I was just looking at all these metrics I could gather from all this information. Well, it was interesting because I was in California at one point, and I got contacted from an engineer from this particular grocery store. And he says, hey, can we do a meetup at store X? And it was kind of funny because I was first thinking, we're going to do a meetup like in the dairy aisle? What? Then it kind of clicked. Oh yeah, they have an office here, not just the grocery stores. So I went and talked with them, and they were asking about Kairos. They wanted to use Kairos in some of their stuff. And then I remembered my little Neo moment in the grocery store, and I said, hey guys, I had this great idea. You should gather all these metrics, and then you can optimize your aisles in your store, right? And then that's when they start looking at each other going, and they're like, oh, wait a minute, that's what you're doing, aren't you? Aren't you? They wouldn't say, but I'm like, yeah, I know what you're doing. It's awesome. Okay, make those lines shorter. But the point of this story is, though, this is going to require a mental shift for engineers of the software you're developing. Now, when a proof point, because we're not just gathering system metrics, we're gathering application metrics. So actually, I'd like to know, how many of you are operations people? And the other engineers, software engineers? Okay, about half and half, that's cool. Because it requires a shift in when you're developing your software to think about the metrics that you can generate while you're writing the code. And say, oh, this would be a very good metric. And it just takes practice. But you're going to want to get into that shift. Like the grocery store, they needed to think, hey, what metrics can we start pulling off these applications that are running within the store? Not just the CPU load or the load on the credit card machines or whatever. You got to get these other metrics out of the systems because that's what's really going to save your bacon. You're going to find, oh, we got a high CPU load. Well, now what's happening in the application? What is the application doing? And if I've got those metrics, I can start pulling that up and bring it out. There's only one problem with this once you start getting all these great metrics is then your boss, he's going to be like, I want more dashboards, give them to me. And it kind of looks like my boss. No, he doesn't. No, because my boss did the same thing. He's just like, he wants more dashboards. He wants to see that data once we start producing it. But this is good because you can do this with Grafana. Grafana is great, and this is where Grafana has really shined for us is in a company. We can create these dashboards. You can copy and paste different things to our boss's dashboard. He said, because we'll go to our stand-up and we'll show him some data, and he's like, oh, I want that on my dashboard. Okay, all right, copy it to a dashboard. We'll make a story adding your dashboards. But here's what's going to happen. It was interesting, and these are some stories of saving your bacon. He who knows the data or knows all. He who has the data knows all. In my team, there's about 4 or 5 engineers, and we have, because 2 of us created Kairos, we have very ingrained into our psyche when we write applications, we report a lot of metrics. But it's interesting because we found that people were coming to us when things went wrong, whether it was our problem or not, because we knew what was going on in the system. And they'd say, hey, well, what's going on? We're not getting any of these. And we're like, okay, well, let me go look. Because we're first thinking, oh, it's our problem. What's going on? Oh, no, that's not our problem. Like, hey, why are you asking us about this? Well, because you guys know. Okay, because we got the graphs, we got the data. So here's some stories that I want to tell about just some systems and what happened in our company and how we were able to use those metrics to solve the problem or avoid the problem. So we had a web service doing dual duty, and it was interesting. The web service, it was just a poor design from the beginning, and we've since getting around it. But it was ingesting events from Kafka, but it was also servicing HTTP requests from another service asking it questions. It was this big indexing system, and so it was pulling in this stuff and indexing it. And it was also servicing these requests from another system to ask about the index. And it was interesting because the system, as load is constantly growing on our system, things started acting really weird, and we started looking at what was going on. And we using the graphs and understanding what the patterns and the usage patterns, because when we built our software, this was actually another good point to use for engineering, is we had a common platform that we built all of our stuff on top of that had built into it a whole bunch of metrics. So for our web services, they would report a bunch of metrics for request times and connection threads and all this stuff. So we had a lot of really good metrics being reported already, and this was really helpful for us when we found that the problem is during this particular campaign, this external service would start hitting our systems more, and we would run out of connection threads. And then it would start this weird flapping thing between ingesting data, and then the queues would back up, and so it was almost like we were DOSing ourselves with what was going on. And we were able to look at the graphs and verify this, and then we solved the problem by just separating some machines and isolating what they did. But it was this data that was helping us along. We have another one that was the Java off-heap memory. This was a very interesting case because we had this system, and we were watching it, and it would run out of system memory, and then it would kill the Java process. But the Java process wasn't running out of memory, which was very odd. We're like, why is it running out of memory? But you could see it in the graphs. You could see the system memory go up, and then it would kill the Java process, but the JVM still had plenty of memory. And it came down to a very kind of obscure feature, if you will, in Java, that when you're making NIO socket connections, it would always copy data to a natively allocated byte buffer. And so it would allocate a byte buffer natively on the heap inside of the system memory, and that doesn't show up in the Java memory. It would get cleaned up with a garbage collection, but the problem was we had allocated so much memory to Java. We had I think it might have been 8 gigs. There was 16 gigs on the machine, and 8 of it was for the Java process. Java had so much memory that the compaction, the garbage collection wouldn't run, and it was filling up the rest of the heap. But the solution was, from looking at these graphs, we're like, oh, well, why don't we just reduce the amount of memory for Java so that the garbage collection hits more often, and when it goes off, it cleans up the rest of the heap. And so the solution was just reduce it. We'd end up putting it down to 4 gigs, and then we could see Java, the garbage collection hit, and then the heap memory would get freed up as well. Kind of a weird thing, but it was something we saw, and it was, there it was. The other one, save the middleman. I like this one because where our team sits, we are in between other services. there's a front end service that the customers look at that connects to ours, and we're feeding off of data from other systems. And I say save the middleman because we ended up being the middleman. Like I said before, people would come to us with problems, or what would happen is we'd see the front end, people that we have customers that say, hey, we're seeing something, what's going on? And we would go look at our graphs and say, it's not us, it's upstream. Because we have metrics consuming metrics from the front and the back end all throughout our system. And we can trail that right through and pinpoint and say, oh, well, it's above us. Go talk to these other engineers that aren't collecting as good of metrics as we are, and ask them. So in that case, I mean, it was saving us because it wasn't our problem. We didn't have to spend the time and resources looking into something that wasn't our problem. We could quickly bring up our dashboards, identify, yep, there's a slowdown upstream. It's not our problem. So mostly what we spend our time doing, with our metrics, is we're avoiding disasters. We're able to avoid disasters because we can see things happening, because we collect all these metrics. Now the last one here is predicting the future. This one I liked. I thought it was kind of fun because at one point my boss comes and says, hey, we need to do some capacity planning for your system. And I'm like, all right. So I decided, hey, you know what? If I look at the previous data and do some calculations on it, I can predict where that's going to end up. And so this graph, now this is not Grafana, this was JSlate. And because JSlate, and maybe this is a little feature request we could do for Grafana. It's because JSlate would let us, you do a query and then you could have a bunch of JavaScript in there. You can kind of custom write it to manipulate the data after the fact. And it was really easy just to edit. You just click edit and you've got JavaScript right there. You type in what you want it to do. So what I did is I used Kairos, and Kairos, I had created this plugin called the Least Squares plugin, or Aggregator. And it's kind of interesting. What it does is it takes, there's a laser right there. So you can see this yellow line. The yellow line is the actual data. It's our incoming events per week, summed over a week. And that's for the past, I think the top one is the past 10 weeks, and then the bottom one is past 25 weeks. And so what I did is the least squares aggregator, I do two graphs. One is the actual data, and the least squares starts there and stops there. And what it does is it takes your data, and then it uses the least squares algorithm to do a best fit line through your data. And then what I did is I took and this was actually kind of fun because my daughter's in middle school, and she's going through algebra woes right now, and I was able to show her, Dad's using algebra, honey, look. And I was all kind of excited, and I showed her the little algorithm, and look, I got to figure out the slope of the line, and then I predict a point out there using the same slope. And I was having a little nerdy moment, and my daughter's just kind of like, okay, great, Dad, that's awesome. Okay, but what I did is I used my least squares algorithm, and I take those two data points, and then I project out 6 months where that's going to be. And then I used the bottom graph, I used the past 25 weeks of data, and it gives me a little better, smoother line that goes out. The point is, if I hadn't have collected all this data, I couldn't use it. So you want to collect it, and that's why I say, pull in more data. You want this data, collect lots of it. Careful how often you do it. And with Kairos, it's easy just to collect a lot of it and keep it, because it's going to save your bacon. That's where it's going to happen. If you don't have it, there's nothing. It's not going to help you. Pull this in, and in this case, I was able to use it for, looking at trends over the past year or whatnot. So that's why I'm hammering that point. Make sure you have the metrics. If not, it's not going to help you. I think that's it. So, any questions about Kairos or this or anything else? Right, so your question is basically, I can write fast to Cassandra, but my reads from Cassandra tend to be slower. And that is true. It has been a pain point for Kairos reading back in time. And really what it comes down to is how many data points you're reading. I mean, I have a graph that I read a year's worth of data, and it comes up within a second. But it's aggregated data. I've aggregated the data to hourly data points. And so I've run an aggregation or roll-up basically across it. And Kairos has a little roll-up mechanism. And I have a script that maintains this roll-up for me. And so, yeah, I mean, so we have, just as an example, at Proofpoint, we have Nagios scripts that do queries and do alerting off of the data. And so they're querying the data constantly. Every few seconds they're pinging Kairos and hitting the last, but they're only looking at like the last 10 minutes of data. And those are really fast, really, really fast. It gets to the point where if you're querying, 1 million data points, that things start to slow down. You'll start to, that's kind of the point at which the user starts to see it. Up to that point, it's kind of like, oh yeah, it's just loading. But once you hit over 1 million data points on the back end, not necessarily, you might aggregate them down to the front end, but if it's the back end is going over 1 million data, your sample size is 1 million data points, that's when the users start to see it. And so for those cases, we will create roll-ups of the data and query because if you're going back 1 million data points, it's like, wow, what are you looking at, man? Because you can't see all that data. You might as well, and you're obviously aggregating at some point anyways. Let's just roll this up into a roll-up and it's faster to query. Now, there are some limitations in what we've done with Kairos, and in the next revision, we're going to parallelize the queries so that we can pull data out of Cassandra faster and put it together faster. Because we do some things in parallel, but it's not quite as efficient as we could. But we've also found that Cassandra scales pretty well, and if you spread that out, and as long as our queries are handling different portions of the data, we can pull that stuff in parallel and be pretty quick about it. The one thing is the way Kairos writes into Cassandra is that we spread the data pretty well across the cluster. So we're really able to utilize the size of your cluster. If your cluster grows, we leverage that. Make sense? So the question is about community involvement. How can we get more? Because it's stagnated there for a while. It's been pretty active. Last few weeks, we've got some more involvement. There was actually a dry spell in the development, and that was mostly just because we don't have company backing that's paying for us to write Kairos code, and so it's usually up to Jeff and myself, and we're doing it at the evening and saying, oh, let's start pulling stuff together. So life happens, it gets in the way, and we can't make the updates that we wanted to, and we pushed out a couple of updates recently. So how can we get the better community involvement? I don't know. I feel like the community is there's actually a large community out there, and so you can take community involvement can be measured a couple of ways. It's like, well, you've got pull requests or you've got a bunch of comments on the board, and if there's no comments on the board, either nobody's using it or everybody's happy with it. So I like to think of the latter myself, but that's just me. But we've had a fairly consistent flow of pull requests and issues coming in. So I think it's more active than it appears. Because I get quite a lot of feedback often from people. A lot of companies have used it for Kairos because Kairos is very, it's lightweight and it's easy to embed in other things or use for specific applications. I know of several companies that have talked to me personally, and I've gone and helped them with their deployments because they've, I can't say what they are, but it's under NDA, but they had specific cases where they were doing part of their research or whatever with Kairos, and that was their driving system because it was lightweight, it was simple to then add their stuff on top of it. And so that's kind of where I think Kairos shines, is because it doesn't, it's never going to do monitoring. I can promise you that, unless somebody makes a plugin to do it. But that's not where I'm trying to hit. And it's kind of cool that Grafana Labs is now doing their monitoring, because that's cool. That's where somebody that's common to all these systems, hey, they can start doing that because it's just querying the database, right? So I would say the perception is not quite right. I think there's quite a bit of activity going on and behind the scenes. I know, like I say, there's been some big companies that I know are using it for a fact. Like I say, I can't see who they are, but you've probably watched their movies, you've gone to their grocery stores, So I'm saying they're using it, and I know they're using it for these type of reasons. So yeah, good question, good comments. Yes, right now what I'm working on is with Kairos is there's actually a lot. Most of what's the direction has been documented in features on the GitHub site. And so there's some cool features that I want to get in there. One of them that I'm working on right now is actually converting the code to use CQL into Cassandra. Right now it's a Thrift-based application. I'm having troubles with that because my personal opinion is CQL sucks. But it was a bad direction by DataStax. But anyway, so I'm working through those right now because the problem is newer versions of Cassandra, they're deprecating Thrift and they're kind of moving away from it. I'm actually working with the ScyllaDB folks, trying to see if we make sure it runs on ScyllaDB as well. So I want to move to that, and part of that change, because I'm kind of changing out some of the guts in Kairos because of the CQL change, is I'm adding in some code to make it more durable. Right now, if a Kairos node blows up, there's a potential to lose some data because there's some in a buffer that's waiting to be flushed to Cassandra. And so I'm adding in some changes there that will make sure that everything that hits a Kairos node will at least be on disk, even if it's not into Cassandra yet. And so just some durability things, some features, definitely making our queries faster. So performance-wise, I can't remember all the features, but there's not really like a big, now we're going to do a moonshot with, we're not doing, it's just, we're going to make the system better and faster. And we've got some ideas where we want to go. And a lot of, like I say, it's on GitHub. Well, thank you guys.